If you've ever stared at a quantitative word problem with multiple price drops or changing incomes and felt your brain lock up, you're not alone. But in the next 6 minutes, we're going to replace that frustration with a foolproof 3-step framework that solves any percentage change question. So grab a notepad and pen. We're going to actively build your quantitative toolkit right now. By the time we're done, you'll see how having a structured visual method removes the guesswork and panic from these tests. Step 1 is mastering our foundation, the golden formula. Take a look at this equation. It calculates simple percentage changes by taking the absolute difference between the final and initial values, dividing by the initial value, and multiplying by 100. Notice how the initial value is at the bottom. This is where most people fail. They fall into the denominator trap by dividing by the new value instead of the original starting point. Let's see this in action. Say the price of milk rises from an initial 14 rupees to a final 15.40 rupees. First, we find the absolute difference between the two prices. 15.40 minus 14 gives us 1.4. Next, we divide that 1.4 by our initial starting price of 14 and multiply by 100. That gives us a clean 10% increase. A percentage change only makes sense mathematically when it is anchored proportionally to exactly where it started. Now that we have the basics, let's move to step 2, the multiplier method. This is how we handle consecutive changes without falling into the addition trap. If a price drops by 15% and then another 12%, you cannot just add those numbers together to get 27. Each drop applies to a newly reduced baseline, so we have to compound them. To do this efficiently, we convert percentage changes into decimal multipliers. As you can see here, a new price is simply the original price multiplied by 1 minus the decrease, or 1 plus the increase. Let's test this. Imagine a fuel price drops by 15%, 12%, and 10% over 3 months, and then rises by 25% in the fourth. To keep the math clean, we assume a starting price of 100. For the first month's 15% drop, we multiply 100 by 0.85, leaving us with 85. For the second month's 12% drop, we multiply that 85 by 0.88 to get 74.8. Month 3 is a 10% drop, so 74.8 times 0.90 equals 67.32. Finally, month 4 is a 25% increase. We multiply 67.32 by 1.25, which lands us at a final price of 84.15. Now we just bring back our golden formula. We take the final 84.15, subtract the original 100, divide by 100, and multiply by 100. The result is a net decrease of 15.85%. Because every single change acts on a brand new baseline, using decimal multipliers is the most accurate way to track sequential trends without losing place. This brings us to our final tool, the Assume 100 grid. We use this to decode word problems that have multiple moving financial parts. Take a scenario where a person spends 90% of his income. His income increases by 20%, and his expenditure increases by 10%. We need to find the percentage change in his savings. Here is the visual grid we'll use to organize this. We're looking at a matrix with columns for income, expenditure, and savings, intersected by rows for the old state and the new state. We always start the old row by assuming a baseline income of 100. Since he spends 90%, his expenditure is 90. The difference leaves a savings of exactly 10. Now we calculate the new row. A 20% income increase makes the new income 120. A 10% increase on the original 90 expenditure brings the new expenditure to 99. With 120 in income and 99 in expenses, a simple subtraction shows the new savings is 21. Finally, we apply our golden formula strictly to the savings column. The difference between 21 and 10 is 11. Divide that 11 by the initial savings of 10, multiply by 100, and you get a massive 110% increase in savings. A confusing paragraph of text becomes a simple subtraction problem once you map the variables into a rigid, visual framework. You now have a complete system: the golden formula for baseline changes, the multiplier method for compounded sequences, and the Assume 100 grid for multivariable word problems. And remember the single most important rule across all of them: your original starting value is always your denominator. With these tools, you are fully equipped to break down and solve any percentage scenario you encounter on an exam or in real-world finance. Let's test that confidence right now. Take a look at this problem. Sarav gets a 60% salary increment. His savings drop from 40% of his old salary to 25% of his new salary. What is the percentage change in his expenditure? Pause the video, draw out your Assume 100 grid, and post your final percentages in the comments to prove you've mastered the framework. Good luck!